another class, I can send the link for you after our class.
Yeah.
Okay. So squash 3 different level curves of Z on the picture chosen A. Okay, 3 different level curves. Yeah, because here we have a 3-dimensional formula, okay? So this, I suppose, is, I suppose, no, I'm sure, this is like a curve or something. But this max is very strange to me in this situation. Because if this max was a normal Z, this is a plan, okay? But I don't understand what your teacher was thinking when he puts max Z here. This is a little strange to me. I don't know. But they want the max value. So this is a problem of optimization. Like the problems of optimization we have in another subjects. Strange this thing in calculus too. But what we need to do? We need to do the Lagrangian thing, like the another class. Okay.
Yeah.
Let me see. We have 2x plus 6y. So and now we need to put the Lagrangian, okay, for these two things. But I was thinking we have more situations more easy to do here. But I don't know. The another form to do this is trying values. So I suppose we need to use Lagrangian multipliers. So, but we have a problem here because we have two constraints, right?
Yeah.
Doing a Lagrangian with two constraints is very hard. And I might thinking what I can do because we need two Lagrangians. Okay. I will name this Lagrangian 1. And we will have Lagrange 2. Okay. And I suppose in this situation, it's interesting if we don't want to use the Lagrangian, we can use the intersection of the restrictions. But in this situation here, we don't have intersections between this line and this line. Okay, but we have intersections with the another limits, like these 4 points. Okay, so this is a interesting thing. Because for me, it's strange. We need to use Lagrangian here. It's a possibility. But I don't know if this is the easier way. Okay. So I prefer first using this because this will be critical points too. Because these points are intersections. Okay.
Okay.
So I will take these points. We have these points. This point is easy to see. 0, 4. 3008 and 80. Okay,
Okay.
4 points. So what we need to do now? We need to test these values in our equation.
Okay.
So for example, the highest point to me is very clear, is that point, this point here. So I can take this equation and put these values in this equation. Why I choose that point? Because we have the bigger coefficient in y, right? So it's very easy to see. The biggest point will be z equals 48, okay? But we need know if this point is this point respect the first restriction, for example, because we have a very big value. So this restriction need to be a rule here too. This is a rule in this problem. So I need to take these values, put here, and see if the value will be bigger than 12, right? So
Yeah.
4 times 0 plus 3 times 8. Yeah, 3 times 8 is bigger than 12. Okay? And I suppose the another situation will be 2, because this value is equals 8, right?
Yeah.
We put the y equals 8, so 0 plus 8 equals 8, right? 2. Okay, so we have a situation easier to work now. The situation is a new restriction. This will show a little strange, but this is a real problem, okay? Let's suppose this is enough to us, but we can do a Lagrangian thing like if we want, okay, if we want, we can do a Lagrangian thing here. But now we don't have 2 Lagrangians, we have only one, because we know the real limit now is 8. So I can erase this and put only one Lagrangian thing. Will be x plus y minus 8. Okay, because we have a extreme situation here, which the sum of these two things is 8, right? Thus, we have this point. So we have this restriction now. Is a restriction more easier to us. And now, what we need to do to work this problem with Lagrangians, like I suppose your teacher can ask to you, we need to do the partial derivatives, right?
Yeah.
But for me, I suppose this answer here is enough to this problem. Actually, I suppose 48 is the answer. But you can do the Lagrangian, so we do the partial derivatives. And the another. Oh my God, this key is L. L, Y, same thing. And only the restriction now. All these things equal 0, so you can equalize the Lagrangians, the lambdas. So we have two lambdas here. This is a little strange because we have two constraints in that situation. I just need to think something. Because we can do this, but we can equalize the things like if we can put a point, for example. I really need to think if this is possible to this problem, okay?
Okay.
Because this is very strange to me. For a while, you can confirm this. Oh my god! You can confirm this answer, okay? Because this is very clear to us now, right? This answer is right because we take the limits, and using the limits, we get this value. We are sure the answer will be in the limits, in the intersections of the constraints, okay? So the biggest intersection is that value. So I suppose we don't need this. And I am thinking if this is possible. I need to think this yet, okay? Because this is a little hard. But this is enough to this problem. This is enough, okay? Just analysis. In Portugal, they love these things. I don't know in your country, but in Portugal, they using this, for example, in the secondary national secondary test. This a problem. This type of problem is very common in this test. In every year in the national secondary test, they have a question like this. Okay, so this is a thing of Portuguese. So this is very strange to me in this subject, calculus too, but they love that subject. So, but I suppose this is enough. This is the way they do in the national secondary test. Okay, so I suppose it's enough to us in that situation. But we have another question here. Oh no, I do all the thing. So far was did. Now what you need to do?
Okay, so now I need to. No, I think this it can be great if we go through the newest test and just can we do it like that? I will send you the test and you will show me how to solve it. What is possible to solve now? Just for me to understand what I should be prepared for.
You can send the test, right?
Yeah, right. Give me a second. Okay, one second. Yeah, here it is.
Let me see. Just a second. Okay. There's some more optimization, other exam. Okay. What question?
Let's just go through, through all of them, like from the first one to
All the questions.
yeah, all
Okay.
of the questions. Just let's go through.
Okay. Okay. This is matrix problems. Matrix problems. Okay. Consider your student number. I don't know your student number. Which will necessarily have 5 or 6 digits. In the case it is write the way, let anyone digit your first student number. Where that's your student number we have. Okay. Oh, you cannot take the answers of your friends because the numbers are different. Okay.
Yeah.
Blah, blah, blah. What size should a matrix Z have to that the matrix multiplication AZM is well defined? But this is very easy. I don't know if you know, but we have some rules to do multiplications of matrix, right? We have some rules. These rules are include the size of the matrix. We need to observe the size of this matrix first. For example, here we have 3 plus 3 matrix, right? 3 lines, 3 rows. Okay? So this is important to us because when we have a situation like that, I will show you. I don't know if you know because this is very strange. For example, if we have a matrix like M lines and rows, and you want to do a multiplication, which a matrix have P lines and Q rows. You need to do this multiplication n equals P, okay? This is necessary. If it's not equal, you cannot do the multiplication, okay? This is a rule.
Yeah.
So if this is true, the matrix, the answer matrix will be a matrix the size M, because the M lines,
Yeah.
plus Q, because the Q rows, okay?
Yeah.
So we have that situation. Just a second. What's, oh my God. Oh, here. We have the station here. I will copy all the things. Okay. So if you pay attention, we have 3
Yeah.
plus 3. Z, we are what to know. We need to know. And M, what's M? M is matrix 2 plus 2. So we need to do all these multiplications, okay?
Yeah.
We can do first the multiplication in the left side. So we need M have the M equals 3, right? We need this. And our answer will be a matrix. I will name it the matrix B. This will be that number of lines and number of rows, okay?
Yeah.
Now I need to multiply by this, so it's necessary and have 2 rows, okay? So we have the answer of this question. M equals 3 and N equals 2. Okay?
Yep.
Very easy. Let's go to the next. What's determinant of A? Yeah, this is we'll need to do some calculus. Very easy, but very boring. Because I don't know your number. But to do this, you can do this for me. We have a
Oh.
lot of ways to obtain the determinant, right? But
Yeah,
the
my
easiest
favorite
way,
is to add the first, yeah, this one, to add the
yeah,
first digits and just do it
we
like that.
have a lot of another ways, but this is the easiest, right? So you
Yeah.
can multiply these things and
Yeah,
and
multiply.
some.
Yeah, I know how to do this. Let's go to the next question, please.
Okay. Just a sec. Compute the entry in row 1 and column 2 of the inverse of M. Yeah, you need to obtain the inverse of M. What's M? Consider also 2 plus 2 matrix M whose determinant M equals 1 over 3 and whose entry row. This is interesting. But is it the only information about them? And whose entry of row 1 and column 2 is we have only this information. This is very strange because our matrix is things I don't know, like the first term, row, column. Row is line, column is column. Okay. Row 1, column 2 is 4. This is very strange, but we need to know this, okay? And we have a interesting way to do determinants in 2 plus 2 matrix. We have a rule a rule easier that involve this is the same way, but I want to talk about the inverse of the matrix 2 plus 2. When we have a matrix 2 plus 2, a generic matrix like A, B, C, D, I don't know if you know, but the inverse is 1, A, D, negative B, C. This is the determinant, okay, if you
Okay.
pay attention. We already know the determinant, right?
Yep.
B minus B minus C, A, okay?
Yep.
So if you want only this term, the row 1 and column 2, maybe we can get this value just using the informations the question do for us, okay?
Yep.
But you can try this for me, okay?
Yeah. Okay.
So you can do and send me a photo.
Okay. Wait. Do we have 1 hour or 2 hours now for our lesson? Teacher. Teacher. Samuel, sorry. Samuel, Samuel, can you hear me? Teacher, Samuel, are you here?
If you have problems to do G, just tell me, okay?
Yeah. I want to ask, do we have 2 hours or 1 hour now? Like,
2 hours.
oh, 2 hours. Okay, great.
If you have some problem, I
Yeah,
can do for you.
give me a minute and I will send you
Okay,
the solution.
no problem. Seems you sent to me. Let me see.
Yeah.
You get negative 12. Negative 12, I get 2. Amazing.
Oh, that's great.
But I think you was a little slow to do this. For me, okay. I don't have
Yeah.
problems. But in your test, this is a problem. Okay?
Yeah.
Because
You're
we
right.
don't have infinite time.
Yeah, I know.
And I suppose this can be more faster. For example, we already know this term outside here is 1/3, right? So we pay attention the things. For example, here is A, here is B, here is C, here is D. And you need to change the things. D minus B, B is 4, minus 4. C minus Y, and A, X. So we have this thing, this fraction thing. We already learned this in our first year in school. Z minus 4 minus Y, X. So we will just need to do the multiplication in this term, because this term is the important for us, because they said this for us. 1 row and 2 column. So minus 12. I think easy. Okay, I think
Yeah.
this is easy. But you need to train more. But
Yeah.
okay, let's go to the next one. No problem.
Yes,
For
please.
me, don't have problem, but I have concerns about your test.
Yeah.
Let me see. This seems harder. Compute the following determinant. Oh my God. This following determinant is a little strange, because we don't have the values of the matrix M. Our matrix M is this. Do you remember? This is M. Oh my God. Technical problem, sorry. So I will copy and I will paste, erase some things. We don't have the values of M, but we can use properties, matrix properties, okay? For example, we have a interesting property about 2 plus 2 matrix. If we have 2 plus 2 matrix, the determinant of M transposed, I don't know if in English this name is transposed. I am sure I am right. Am I right?
Yeah.
Transposed, okay. Is equal a determinant of the normal matrix. This is cool, because we have a transposed here. And we have another property, interesting property. If we have a constant multiply a matrix in the determinant will be the constant to the power of the number of the size of the matrix. Because to do a determinant, the matrix need to be square. Okay, so this matrix is square. This matrix need to be a square too. The square is the same number of rows and columns. Okay.
Yep.
So we have this thing to do easier our problem. Okay.
Yep.
So we have in this situation here determinant. Oh my God. We have the determinant of the multiplication of 2 matrix for a while. Okay, so we have another property, interesting property here, because we know when we have a multiplication inside the determinant, this is the multiplication of the determinants. Okay,
Yep.
I can do the determinant of this and multiply the things. So this is things you need to record. We need to memorize, okay? Because it's very
Okay.
important in your test. And I suppose the teacher will not put this in your test, in your formulary, okay?
Yeah.
These two things is equal, so we know this will be the determinant of m squared. Okay, and we know the determinant of m. Do you remember? The determinant of m is 1 over 3. So I think is enough to you finish the whole thing. Okay, the whole thing.
Yeah.
You can finish to me. Okay, this is an important test for you now. So when you finish, just send me a photo, okay?
Okay. Yeah. Okay.
You do something. Let me see.
Yeah.
Let me see. Just a second, bro. Just a second. Because we have technical problems all the time. But okay, I will copy and I will put here. But I don't have more space in this screen, so this will be not didactic. But let me see. You get 4. Yeah, 4 is the answer.
Yeah.
You do right. Amazing. Congratulations.
Thank you very much.
Amazing. Let's go to the next. I need to save this first. Just a second. Okay. Another screen. Okay. Which of the following options is an eigenvalue of matrix? Okay, we need to do the eigenvalue of this matrix. Eigenvalue, okay. The matrix B, but what is matrix B? I don't remember. Let me see. B. What's B? Ah, B is this. B is another matrix. Okay, with a lot of numbers and stuff, but I don't know your numbers, but we can think some things without your number. For example, we can note this matrix is a triangular upper matrix. Okay?
Okay.
If we think something, because what is a triangular matrix? Is this matrix we have values, specific values, okay? In the lines, for example, here we have 2 zeros and here 2 zeros. So some things is more, some things is easier to take here. So when we have a triangular upper matrix in the first line, this is the case, we know this is the eigenvalue, okay?
Yeah.
So I don't need to do any math, any calculation to take. I just know because the structure of this matrix, okay? This is the eigenvalue. And we have another eigenvalues. For example, the another eigenvalues is the eigenvalues of this submatrix here, okay?
Yeah.
And what we need to do to take the eigenvalues is very easy. We need to do the determinant, okay?
Yeah.
We need to do the determinant. So I will do the math because to me, seems we don't need to know the values of anyone. Your teacher was little troll here. He does a trick here. Because to do the eigenvalue, I need the determinant. So I will do the determinant of this submatrix here to take the another eigenvalue, okay? So I will have, you know, do the determinant in a 2 plus 2 matrix, okay? So this line minus this line here, okay?
Yeah.
But this line here have negative, negative, so all the things is positive, okay?
Yeah. Okay.
So we don't need to know the any1 value to know this calculation is 0, okay? So
Yeah.
know the another eigenvalue. The another eigenvalue is 0. 0 equals 0, right? So we have this eigenvalue here. Okay?
Yeah.
Okay. So the eigenvalue is 0, just like that. Very easy, very, very easy. Okay. So this is the answer. C. Very easy. Classify the quadratic form QB associated to matrix B. Quadratic form? Okay, okay. Sometimes we write the quadratic forms using matrix, okay? For example, in your situation, we have this matrix here. This is the matrix we need to observe. And what we just do in this problem here? We get the eigenvalue 0, right?
Yeah.
Here, value 0. So we have a definition when we have the eigenvalue 0. The definition is the quadratic, the quadratic form associate is not defined either positive or negative. So we have a because our eigenvalue is 0, our quadratic form is semi-defined positive. Okay?
Okay.
Because it's 0. To be a semi-defined negative, we need a negative value. Okay? And 0 is not a negative value. Okay? So the name is defined positive. This is a definition. You don't need to do math to obtain this value. If you pay attention, we don't need to do math, the real math, the hard math, in any question in this problem, right?
Yeah.
So very easy, this problem to us. Let's go to the next one. Oh my God, this is Stranger Things here. Like the Netflix TV show. Stranger Things.
Yeah.
Let me see. Find the correspondence between the given functions in their respective graphs and contour plots. Show below. This is very boring because we don't know the curves of 3D equations because it's very hard. It's very difficult to see and to work. We are not. We usually don't work with these things, right? But we can try. For example, we have some things very similar here. If we are a little intelligent, we can associate this with this, for example, right?
Yeah.
Yeah. So I will put the same color. Okay. For
Okay.
example, here with this.
Yeah.
Very easy.
It's with this. A with
this.
third. Yeah. And this with.
Very easy. Very okay. The problem is the equations, but you can try. Okay. You need to observe. You need to remember. For example, this thing normally have an equation without a variable isolate like this. So you can work with this equation to obtain some of these things. I will show to you. If you square two sides, right?
Yeah.
You will obtain the equation of a sphere. Do you agree with me?
Let me see. Okay, so we have y minus x squared minus y squared.
Yeah, if you put this minus x squared and minus y squared to the left side, right? So you will be x squared plus y squared plus z squared equals a number. This number is the radius of your sphere.
Oh,
right?
Yeah.
Like the sphere. So
Yeah.
this is the 2, okay? And the contour plot is D. So I do the easiest, the easiest one. You will think a little bit about the another plots, okay?
Okay.
Okay, I need to go to the bathroom. So
Yeah,
when I
sure.
come back, you say to me what you think.
Yeah, okay.
So, do you think something?
Yeah, I do actually. So first of all, it looks for me. Yeah. First of all, the first function is
This one?
no, that's
Here?
yeah.
Don't know,
I think
but can be. So here is letter B2. Ah, sorry.
no, no, no.
Yeah.
Here,
Nope.
I think here is number 3 and
3.
number
This one.
yeah, probably.
So is A, right?
Yeah, probably it is.
Okay. We can see. Another one.
And another one is probably number 3 is our 4. No, next one. Number 3.
Ah, okay.
Mm.
I will put the same thing we are seeing because this is very confused.
Oh,
Okay. So is letter A and here. Oh my god, I am a little confused. C, right?
yeah, 4C.
Sorry.
And
So
here is
one.
probably 1B.
Yeah. 1B. Okay. We can think something. For example, this 2 is very easy. I will not think about it. But you can think just a little about the domain of this function here, right?
Yeah.
What's the problem with this domain? We have some value where this will have infinite, a divergence. No, we don't have. But we have a situation where we have a value will be less than other values. For example, no, the bigger of the another values. When we have y and x equals 0, do you agree with me? Because if you put 0, you will have the more few value, the bigger value, okay? Because, for example, if you put another number in x and y, for example, 1, you will have 1 over 4, right?
Yeah.
1 over 4. If you put -1, because this thing is squared, will be 1 over 4 too. So the value you put to have the bigger value is 0. So we have a maximum point in this function. Because this, you are right, okay? So you can think about these little things, okay? To understand the question when you don't know the behavior of the curve, okay? But you are right. You are right in your answer. Okay. Very amazing, very cool. Tomorrow is your test?